Pluto is a distant object in our solar system that many people used to think of as a planet. In the past, it was grouped with other planets orbiting our star. This icy body caught the attention of many scientists who study the night sky. For years, it was part of planet models in school classrooms. But later, experts changed Pluto's label and called it a dwarf planet. The reason was its strange orbit and smaller size compared to others. Even though its title changed, Pluto still holds mystery in space. Its odd path and lonely place make it fascinating to astronomers. Recently, famous scientists like deGrasse Tyson and Michio Kaku talked about Pluto again. Their comments started new talks among experts and the public. They mentioned a possible future event involving Pluto and Neptune. These two distant planets may one day come close in their journey around the Sun. The idea of a Pluto and Neptune collision shocked many viewers. People asked if such a thing could happen in the real universe. While it sounds like science fiction, it's something scientists are actually watching. Our solar system is full of surprises, and nothing can be fully ruled out. Pluto's orbit is not like other planets that travel in near-perfect circles. Instead, Pluto moves in a stretched oval, or elliptical, path through space. This shape causes Pluto to sometimes come closer to the Sun than Neptune. It crosses paths, yet they never touch. Adding to the strangeness is Pluto's tilt. Its orbit is slanted by about 17 degrees compared to the flat path the planets follow. Because of this tilt, Pluto's path takes it far above and below the main plane. This plane is where most of the solar system's motion happens. Pluto only spends about 20 years of its 248-year orbit inside Neptune's path. The rest of the time, it's farther away, in deep space. This pattern made scientists wonder why the two have never crashed. Their paths seem to cross, but they remain safely apart. The reason lies in the balance of forces from other massive objects. Planets like Jupiter and Saturn play a role in this careful dance. In fact, the system is so complex, it's explained through something called the three-body problem. This means three objects pull on each other with gravity in space. Trying to calculate their motion takes advanced tools and simulation programs. Computers help track how the Sun, Pluto, and Neptune interact. Another key factor is a motion called libration. This ensures that when Pluto crosses Neptune's orbit, it always does so safely. Pluto and Neptune remain at least 90 degrees apart in angle when their paths meet. This stops any real threat of impact. Pluto also moves up and down in its orbit in a pattern called scope libration. This keeps it above or below Neptune when they are close in their solar route. On top of this is something known as VZK wobbling. This refers to how gravity tugs and shifts Pluto's path in a repeating way. These tiny wobbles help Pluto stay in a steady orbit even though it looks unstable. Over time, they prevent sudden changes in its route. So while Pluto looks like it's headed for danger, it's actually protected by gravity. The system corrects itself with each orbit. The three-body problem helps scientists understand how such balance is possible. It explains why Pluto has not yet crashed into Neptune in the night sky. Even tiny changes in Pluto's original path could have made it unstable. But over millions of years, the system has kept working. Modern computer models have confirmed that Pluto and Neptune are locked in a 3-to-2 resonance. For every 3 orbits Neptune makes, Pluto makes 2. This lockstep motion acts like a shield, keeping Pluto from danger. It's one of nature's great balancing acts in space. Jupiter and Saturn also pull on Pluto in just the right way. Their gravity keeps the smaller body in check across its long journey. Without these forces, Pluto could have been thrown out of the solar system. Or it might have collided with Neptune long ago. This amazing coordination shows how complex and beautiful space really is. Every planet, big or small, has a role in the cosmic puzzle. Pluto serves as a reminder that even the smallest bodies are important. Their orbits teach us about the hidden rules of the universe. Even with this knowledge, Pluto's path still has mystery. Tiny changes in speed or direction could lead to new outcomes. This is why scientists constantly run models and collect data. They want to predict how Pluto will behave far into the future. But even with the best tools, predictions are hard. A small difference today might create a big change over billions of years. Because of this, scientists continue to study Pluto's strange movement. Each new discovery gives us clues about what lies ahead. Michio Kaku has warned that small shifts in gravity might change Pluto's future. This idea comes from deep research in space physics. Neil deGrasse Tyson agrees that Pluto's orbit needs attention. He supports the idea of watching it closely as the solar system evolves. Even though they don't predict a crash soon, they say it's possible someday. Over long timescales, space can behave in unexpected ways. Pluto may one day swing closer to Neptune, changing its orbit. That would be a major moment in astronomy, visible in the telescope sky. But for now, Pluto remains safely in place. It's moving on its long, cold path at the edge of our solar system. While Pluto's current orbit looks stable, it's still influenced by gravity from all directions. The solar system is always in motion, shifting like a galaxy dance. Over billions of years, small changes add up. This could someday move Pluto into Neptune's lane. The Sun itself is changing too. One day, it will become a red giant, growing larger than Mercury's orbit. This massive change in the star's size could shift every planet's path. Even Pluto could be affected, as gravity patterns change in space. Later, the Sun will collapse into a white dwarf. This collapse will again reshape how gravity works in the solar neighborhood. At that time, the outer planets like Neptune and Pluto might move differently. Their peaceful orbit might turn into something chaotic in the sky. Even a small comet or asteroid flying nearby could disturb Pluto's path. These space rocks are often invisible until it's too late. That's why astronomers keep watching Pluto and Neptune. They use strong telescopes and satellites to monitor their slow motion. The risk may be small, but it's not zero. Space is full of variables we don't fully understand. Tyson and Kaku both support more research. They believe we need better data to prepare for cosmic surprises. New space missions might help answer some of these deep questions. Sending probes near Pluto can give us more accurate details. Images from missions like New Horizons have already helped. They showed us Pluto's icy mountains and wide plains in clear color. These scenes tell us Pluto is not just a dead rock. It's a complex world with its own weather and landscape. Understanding Pluto's behavior helps us learn about other dwarf planets too. Some of them orbit even farther from the Sun. They might follow similar orbits, crossing paths with Neptune or other planets. Studying one helps us understand them all. Pluto's orbit challenges our understanding of how the solar system works. It shows how complex motion becomes when many objects interact. Sometimes, even scientists get surprised by what they find. A new moon or object can change the whole system model. That's why space remains a mystery to explore. We can always find something new in the black sky. The idea of a Pluto-Neptune collision sparks the imagination. People wonder what it would look like if two worlds met. The impact would be enormous, causing shockwaves through the region. Ice, rock, and dust would scatter across the solar field. Such a crash could even affect nearby moons. Smaller bodies would get thrown off course, creating new hazards. It could send objects toward the inner solar system. In rare cases, this might even bring danger to Earth's orbit. Though unlikely, it's a possibility worth watching. Space surprises us when we least expect it. That's why computer models matter so much. They let us test future paths without needing to wait hundreds of years. By changing tiny details, scientists see how Pluto's orbit might shift. Some results show stability, others show future crashes. These tests help us prepare for what's ahead. They also improve our knowledge of space rules and gravity motion. Even if Pluto never hits Neptune, their connection teaches us a lot. It helps explain why some objects follow strange orbits in the galaxy. The more we learn about Pluto, the more questions we have. Every mission adds new pieces to the puzzle of space. Pluto is far, cold, and quiet, but it speaks loudly to science. It shows us how much we still don't know. The interest in Pluto has grown again because of new data and public excitement. Its icy surface and hidden core make it a star topic again. Even schoolchildren are asking why Pluto isn't a planet. This keeps the space debate going across classrooms and media. Pluto's journey through the cosmos is far from over. It will circle the sun for millions of years more, touching new parts of space. And scientists will keep watching, calculating, and wondering. Will anything change? Will new planets be discovered out near Pluto? Our space tools are getting better with time. Future satellites and telescopes will reveal more secrets from the distant zones. Until then, we keep learning from Pluto's slow dance. Its icy orbit is both a challenge and a guide in the sky. Every time we look up, we're reminded that the universe is vast, deep, and full of movement. Pluto teaches us patience and curiosity. It shows how science is always changing with every orbit and star. As long as questions remain, the study of Pluto will continue. It stands as a tiny but powerful part of the great space story. Subscribe to our channel and thanks for watching.